Hey students, today we're going to learn how to prove lines parallel using the converse of theorems you learned in 3.2. The objective is for you to determine whether two lines are parallel. This lesson relies on the converse of the parallel line theorems that we learned the last couple days. So we're going to review converse here. If you wear a sweater, then you are cold. You can pause now and start the video again, and you can see the answers to the rest of these questions. All right, here are the postulates and theorems we're going to use. These are actually the converse of the corresponding angles postulate. And if two lines on a transversal form corresponding angles that are congruent, then the lines are parallel. And the angles would be marked like this. The diagram that models postulate 3.2 is the second one here, where you have corresponding angles. 1 and 2 are corresponding angles, and if those two angles are congruent, then L is parallel to M. Okay, some more converse theorems. The converse of the alternate interior angle theorem, the converse of the same side interior angles theorem, the converse of the alternate exterior angles theorem. In theorem 3.4, so if we're using theorem 3.4, that's the converse of the alternate interior angle theorem. Then we would have that angle 4 is congruent to angle 8. Those are alternate interior angles. And that would be enough to show that B is parallel to C. Theorem 3.5, that's the same side interior angle theorem. That would be angle 3 and angle 8. They're same side interior angles. And if they're supplementary, then B would be parallel to C. Theorem 3.6, that is the converse of the alternate exterior angle theorem. So if angle 1 and angle 7 are congruent, then B is parallel to C. Problem 1, if angle 2 is congruent to angle 3, those two angles are congruent. Those are alternate interior angles using line A as a transversal. So if those two angles were congruent, then line N and line M would be parallel. And here's how we can justify that. So we're given that angle 2 is congruent to angle 3. And we notice that angle 2 and angle 3 are alternate interior angles. Using transversal A. So by the converse of the alternate interior angles theorem, N is parallel to M. which lines are parallel if angle 6 is congruent to angle 7? All right. Angle 6 is congruent to angle 7, it's given. Angle 6 and angle 7 are same side angles. Angle 6 and angle 7 are corresponding angles. So I can use postulate 3.2 to prove the lines parallel. Using angle 6 is congruent to angle 7, lines A and B, not A and B, lines L and M are parallel, and the transversal is D. All right, here we're going to write a flow proof. Flow proof is kind of like an algorithmic, where you kind of combine a couple things together to show that they end up meeting in one place in the end, which happens to be whatever we're trying to prove. All right, so here we're going to try and prove that given the measure of angle 5 is 40 and the measure of angle 2 is 140, we're going to try and prove that A is parallel to B. Well, one thing you might notice is that angles 2 and angle 5 are same side interior angles, and so we have something that says if same side interior angles are supplementary, then the lines are parallel. That's kind of the direction we're going to go here. We'll start by writing down our given. So the measure of angle 5 is equal to 40. And the measure of angle 2 equals 140. And those two things are given. From those, we get the measure of angle 2 plus the measure of angle 5 is equal to 40 plus 140, which is equal to 180. And that is the additional property of equality. And since those two angles add up to 180, we can say that angle 2 and angle 5 are supplementary angles. And that's by the definition of supplementary angles. And finally, that leads us to A is parallel to B. And that is the converse of the same side interior angle there. Here's the answers to these questions. All right, problem 3. If the measure of angle 1 is 65 and the measure of angle 2 is 115, are the lines A and B parallel? Explain. I believe they are, since angle 1 and angle 2 are same side interior angles. And the measure of angle 1 plus the measure of angle 2 equals 180. Angle 1 and angle 2 are therefore supplementary by the definition of supplementary angles. And so, by the converse of the same side interior angles theorem, A is parallel to B. If you want to pause now, I'll check back for the answers. All right, problem 4. What is the value of x for which A is parallel to B? Well, if A is parallel to B, then that means these two angles, which are same side interior angles, they need to be supplementary. So 48 plus 3x plus 3 has to equal 180. And if we simplify that, we get 3x plus 51 equals 180. And if we subtract 51 from both sides, we get 3x equals 129. And if we divide both sides by 3, we get x equals 43. So if x is 43, then the two angles are supplementary angles and A is parallel to B. And that concludes the lesson. Thanks, Lexi.